In this video, I'm going to talk about the indirect utility function, how to derive this function, and I will also discuss about some properties of indirect utility function. So before going to this topic, let us first review what a direct utility function is. So a direct utility function shows the utility that can be attained from the consumption of different goods and services. This shows the utility as a function of the quantities of the commodities. So utility here depends directly on the quantity of commodities X. Consider a case of two commodities only. So the utility function U equals x1 to the power 1/4, x2 to the power 3/4. So this utility function shows the utility attainable from the consumption of these two goods. So this is called direct utility function because it shows the utility directly as a function of the quantity consumed of the commodities. So now we go to indirect utility function. Indirect utility function means that it shows utility attainable from the consumption of the goods and services, but not directly. So for this, we simply have to review that utility it depends on the quantity of goods consumed, but the quantity of goods demanded further depends on the prices of the goods and the consumer's total income or wealth. So the direct utility function goes from here to here, that is utility attainable from the consumption of goods. So direct utility function is a function it is a function on the quantities of the commodities. Now the indirect utility function shows the maximum utility that can be obtained as a function of prices and level of income. So this indirect utility function, it is a function of prices and income or wealth, and it shows the maximum utility attainable at different sets of prices and different income levels. So this is generally denoted by V, and it depends on prices and income, not on the quantities of commodities. Yeah, it depends on the quantities, but indirectly it is a direct function of prices and income level. So this is simply the indirect utility because prices and income determine the quantity of good X demanded, and that in fact determine the utility. But this part is not explicitly introduced here. So here utility is simply the function of prices and income level, so it is called indirect. Now let us derive the indirect utility function in case of some types of preferences. The first example here is the case of Cobb Douglas preferences. So the Cobb Douglas, let us take a simple example. The Cobb Douglas preferences, they can be expressed in the form of utility x equals, so pi runs from 1 to n xi to the power alpha I. So here I goes from 1 to n. So but for our case now, let us consider the case of two goods only, and let us consider a specific example. Utility from x1 x2 is x1 x2. So here alpha is 1 in both cases. So now let us find the indirect utility function. So to find the indirect utility function, the general procedure is, first we find the optimal commodity purchase, or the optimal amount of x that the consumer will purchase as a function of price and income. So we find xpw, that is the amount of x that the consumer is going to buy as a function of price and income level. This is nothing but the Marshallian demand function. So we first find the Marshallian demand function, and after that we substitute this in utility function. So it is a two-step procedure. The first step is find the Marshallian demand function, or the optimum commodity purchase as a function of price and income, and the second step is to substitute the value of those optimal quantities of x in the utility function. So now let us apply this procedure to our example. We first find the Marshallian demand function from this utility function. So we will not go in detail stepwise to find the Marshallian demand function in this case, because we know that in case of Cobb Douglas preferences and two commodities, let us say x1 to the power alpha, x2 to the power beta, the Marshallian demand function x1 pw is simply given by alpha over the sum of the exponents times w over p1, and x2 pw equals to beta over the sum of the exponents times w over p2. So this is the general formula we derived in an earlier video. Now we use this formula to express the optimal quantity of x1 and x2. So the optimal quantity of x1 and x2 is x1 pw. So this p is a vector which includes p1 and p2, but its w is the consumer's wealth or income. So this is, so here alpha is 1 and beta is 1. So the Marshallian demand function for the first commodity is 1 over 1 plus 1 times w over p1, which is w over 2p1, and the Marshallian demand function for the second commodity is the same, w over p2. So this is w over 2p2. So now finally we substitute these demand functions in the utility function, and we get the indirect utility function. So now let us do that. So our utility function is utility function is u1 x1 x2 is x1 times x2. So we substitute this x1 and x2 here. So now this utility is not function of x1 and x2 but function of w, p1 and p2. So we write this utility, so this becomes now x1 pw and this becomes x2 pw. So now substitute the value of x1, which is w over 2 p1, and the value of x2, which is w over 2 p2. So this is denoted by v pw because this is the maximum utility attainable from the consumption, and it is a function of prices and income. So this is 1 over 4. So this is w square over p1 p2. So this is the indirect utility function in our case. This is the indirect utility function in case of our Cobb Douglas type of utility function. So we see that the indirect utility function is a function of wealth or income and prices. So it is worthy to discuss some of the properties of the indirect utility function. The first property of this is homogeneous of degree 0. Homogeneous of degree 0 in prices and income. This means if we increase prices and income by some constraint ratio, the maximum utility attainable will not change. So to show this, let us increase w by k times and prices by k times. Now this becomes 1 over 4 kw square over k times p1 k times p2. So what we did here is we just multiplied w by k and p1 p2 by k, and this becomes k square over k times k square times 1 over 4 w square over p1 p2. So this cancels, and this is the same as the original level of utility that is here. So thus indirect utility function is homogeneous of degree 0 in prices and income. So now let us go to property second. Second property is that it is or the indirect utility function, or V, is strictly increasing in wealth. So what it means is that if wealth increases, the level of maximum utility that is attainable from the new level of wealth, other things remaining the same, will surely increase. So to show this, we just can observe that the derivative of the indirect utility function with respect to wealth is strictly greater than 0. Now from the equation we can show this. So we can show that the derivative of v with respect to w is strictly positive. So the derivative of v with respect to w, this is simply 1/4 p1 p2. This is constant quantity for now, and derivative of w square is 2w. So this is strictly greater than 0 because w, p1 and p2 cannot be negative. So thus the indirect utility is strictly increasing in the level of wealth. So now we go to property third. The third property says that the indirect utility it decreases with the price level, or it is decreasing in price. So decreasing in P. So to show this, we just can observe that its derivative with respect to price is less than 0. So now here we can calculate del V over del P1. So this is 1/4 times W square over P2. These are constant, and we just differentiate 1/P1 only, and the derivative of 1/P1 is, so this becomes P1 to the power -1, and its derivative is -1/P square, P1 square. So we see that this value is strictly less than 0, and we can also show that del V or del P2 is 1/4 W square over P1 times -1/P2 square, and this is also strictly less than 0. And this shows that the indirect utility function will be decreasing in prices. And finally, some other properties. One simple property is that the indirect utility function is continuous. So since the utility function is continuous in prices and income. So since the utility function is continuous, this will be continuous. And the last property, which is very much important, the property is about Roy's identity. So the Roy's identity tells us that we can derive the demand functions xpw from the value function or from the indirect utility function by simply taking a ratio of partial derivatives, and this can be derived as minus times the partial derivative of the indirect utility with respect to some prices divided by the partial derivative of indirect utility with respect to the level of wealth. So this identity is called Roy's identity, and we will show that the Roy's identity holds in our case. So now let us first find the derivative with respect to P1 and see what happens. So this is minus times del V over del P1 divided by del V over del W. So this is minus times So if we differentiate this with respect to P1, this becomes 1 by 4 W square over P2 is constant coefficient. So we keep it as it is and we differentiate 1 over P1 only. So this is minus 1 over P1 square. So divided by the derivative of V with respect to W is simply, so this is 1 over 4 P1 P2, so 1 over 4 P1 P2, so this is constant coefficient and the derivative of W square is 2W. So now this becomes so this is negative and negative is positive, so 1 by 4 cancels. This is 1 over 2, so this is W square, so 1 W here and W cancels, so this is W only. Now this P1 P2 comes up here, P1 P2 in the numerator, and this P1 square goes here. So this is P1 gets cancelled, P1 gets cancelled, and sorry, there is another P2 here, P2. So this P2 also gets cancelled, and what remains is W over 2P1. So this is nothing but the Marshallian demand function we derived a few minutes ago. So this is the Marshallian demand function for the first commodity X1 PW. So now we can find the derivative of V with respect to P2 and divide it by the partial derivative of V with respect to W, and find the Marshallian demand function for the second commodity. So now this is del V over del P2 is 1 over 4 W square upon P1 is a constant coefficient, and we find the derivative of 1 over P2 only, so this is 1 over P2 square divided by, so this is 1 over 4 P1 P2 is a constant coefficient now, and we keep as it is, and the derivative of W square is 2W. So again this 1 by 4 cancels, W and square cancels, negative becomes positive, so what remains is 1W here. So this P1 P2 goes here, here is 2, and is a P1, and here is P2 square. So P1 gets cancelled, P2 and square gets cancelled, and it is W over 2P2, which is nothing but the Marshallian demand function for the second commodity. So in this way, the raised identity helps us to derive the Marshallian demand function from the indirect utility function. Thank you for watching this video, and please subscribe to my channel for watching more videos in the future.